AI is moving past generate a pretty asset and into structured creation, objects with stable parts, editable layers, and geometry that survives reuse. That matters because robotics, games, AR, and design tools don't want one-shot outputs. They want controllable components you can move, recombine, and script. The bigger trend here is a shift from opaque generation to representations that preserve semantics and structure. In the next few minutes, you'll see how that shows up in 3D correspondence, part-aware 3D generation, and layered image editing at scale. Let's explore the first paper, Category Level 3D Correspondence in Camera Space via Morphable Object Priors. This paper reframes category-level object understanding as monocular 3D correspondence in camera space, where the task is to predict the same semantic point across two RGBD views without pose normalization. To make that measurable, the authors introduce HouseCore 3D, the first large-scale benchmark for this setting, built from 178K image pairs spanning 50 household categories and 280 object instances, with key points annotated directly on CAD meshes, plus Emoto labels for occluded regions and explicit symmetry handling. They then propose Morpheus, a morphable object prior that disentangles canonical shape, deformation, and 6D pose. So correspondences emerge implicitly from shared template topology rather than from explicit correspondence supervision. Morpheus uses a DNOV2 ViteTS encoder, a learned deformation field over a hybrid SDF to mesh template, and mesh transfer via barycentric coordinates in camera space. On HouseCore 3D, it reaches 31.3 PCK at 0.1 for 2D evaluation, 43.7 for 3D modal correspondences, and 41.5 for 3D amodal correspondences, outperforming GenPose++ at 26.7, 37, and 34.3 respectively. On a filtered real-world subset of Omni6D pose, it generalizes to 44.7 PCK at 0.1 inches 2D and 34.8 inches 3D, showing that semantic 3D alignment can be learned from geometric supervision alone, provided the model is anchored by a shared morphable prior. Let's explore the second paper, CubePart and Open Vocabulary Part Controllable 3D Generator. CubePart, from Roblox and Stanford University collaborator Manish Agrawala, introduces an open vocabulary, part controllable 3D generator that turns a global text prompt plus a user-specified part schema into a coherent, multi-mesh object, with each schema element becoming a distinct, structurally complete part. The system is built on a two-stage rectified flow diffusion architecture. Stage 1 trains a compact Qwen-VL conditioned MMDIT with 1, 9B trainable parameters on about 4, 7 M mesh text pairs to generate a holistic shape latent, then fine-tunes it with schema-aware prompts, so requested parts are not omitted. Stage 2 reuses the Stage 1 weights and adds 4 zero-initialized cross-part attention blocks to decompose the full latent into part latents while preserving global coherence. To make this possible, the authors also construct a large open vocabulary 3D part dataset of 462K assets and two 2M parts over 11 times larger than Partverse XL using 1-4 view set of mark rendering and GPT-5 to cluster and name parts automatically. On part Obviverse Tiny, CubePart outperforms prior part generators, reaching 0.251 chamfer distance and 0.743 f-score at the part level and 0.048 chamfer distance and 0.974 f-score at the holistic level, and the generated assets can be plugged directly into Roblox-style game behavior scripts for driving, flight, and weapon effects without manual post-processing. Let's explore the third paper, MRT Masked Region Transformer for Layered Image Generation and Editing at Scale. MRT, developed by Canva Research, is a 20B parameter masked region transformer for layered image generation and editing that unifies text to layers, image to layers, and layers to layers in one masked regional diffusion framework. Trained on over 10M multilingual design samples, the model operates on a full-size canvas with an overflow-aware background layer, so foreground layers can extend beyond the visible boundary instead of being cropped, which is crucial for editability and reuse. For inference, MRT applies diffusion distillation to compress a 5-0 step teacher into an 8-step generator, reaching near real-time multi-layer synthesis while preserving quality. On image to layers, MRT beats Qwen image layered on merged image quality and in user studies achieved 79.5%, 68.9%, and 82.6% win rates for layer quality, integrity, and granularity, while also delivering up to 108.5 times speedup at about 20 layers and reducing peak GPU memory by 10.5 times to 23.6 times. The paper also shows that scaling matters. Moving from a 13B Flux 1 based baseline to Qwen image reduces FID from 17.79 to 16.15 on the same 0.5M subset, and expanding to the 10M dataset further lowers FID to 15.63. Overall, MRT establishes a new benchmark for editable, semi-transparent, layered generation at scale. That's a wrap on today's AI paper highlights. Thanks for watching.